Good day everyone! In this video, we will discuss about solving logarithmic equations. These are the steps in solving logarithmic equations. For the first one, using the properties of logarithms, express the given in single logarithmic expression. Number 2, if needed, express the equation from step 1 into exponential form. Number 3, solve for the indicated variable. And number 4, check your answer. Let us try to solve some logarithmic equations using the provided steps earlier. For the first given, solve the logarithmic equation logarithm of x plus logarithm of 3 equals 2. As stated in step 1, let us express the given logarithmic equation logarithm of x plus logarithm of 3 equals 2 into a single logarithmic expression. Notice that we have addition here, so by using property number 1, we will be multiplying x and 3. So we will have logarithm of 3x equals 2. Next step, if needed, let us express this equation into exponential form. Notice that we do not have a base here, so therefore, it means that the base is automatically equal to 10 because this logarithmic expression is what we call common logarithm. Therefore, writing this logarithmic equation into exponential form, we will have 10 raised to 2 equals 3x. For step number 3, we need to solve for the indicated variable. Since we have 10 squared equals 3x, simplifying 10 squared, we will have 100 equals 3x. Since we are solving for x, we will be dividing both sides by 3. Therefore, the value of x is equal to 100 all over 3. Finally, for step 4, we will be checking if our answer is correct. To do that, we will be substituting x equals 100 over 3 to our given logarithmic equation, logarithm of x plus logarithm of 3 equals 2. So we will have logarithm of 100 over 3 plus logarithm of 3 equals 2. Combining these two logarithmic expressions, we will have logarithm of 100 over 3 times 3 equals 2. Next, simplifying 100 over 3 times 3, we will have logarithm of 100 equals 2. Next, looking at the expression, since we have a common logarithm here, automatically the base here is 10. Notice that for us to have 100 as our power, then 10 should be raised by 2. Hence, we have here 10 squared equals 100, therefore 100 equals 100, which means that the value x equals 100 over 3 satisfies the given logarithmic equation. For the second one, we have logarithm of x to the base 3 minus logarithm of 2 to the base 3 equals 2. Again, for step 1, we will be expressing the given logarithmic equation into single logarithm, and to do that, we will be applying property number 2 because we have a subtraction here. Since this is subtraction, it means that we need to divide x and 2. So we will have logarithm of x over 2 to the base 3 equals 2. Next, for step number 2, express the resulting equation in step 1 into exponential form. To do that, determine the base, the exponent, and the power from step 1. In here, we have the base equals to 3, the exponent equals to 2, and the power equals to x over 2. So writing it into exponential form, then we're gonna have 3 squared equals x over 2. Next, for step 3, we need to solve now for the indicated variable x. To do that, we need to simplify first 3 squared, which will give us 9 equals x over 2. To solve for x, we need to do cross multiplication. Since we have 9 here, so automatically the denominator is equal to 1. So when we do cross multiplication, we're gonna have 1 times x, which is x, equals 9 times 2, which is 18. Therefore, the value of x is 18. Finally, for step 4, we will be checking if our answer x equals 18 is correct. To do that, we will be substituting 18 to the variable x on our given. So we will have logarithm of 18 to the base 3 minus the logarithm of 2 to the base 3 equals 2. Since this is subtraction, so we will be dividing 18 and 2, giving us with logarithm of 9 to the base 3 equals 2. Writing this into exponential form, we gonna have 3 squared equals 9, and 3 squared is actually equal to 9. Notice that the left side is equal to the right side, which makes the statement or the given logarithmic equation satisfied. For our last example, we have the logarithm of x plus 3 to the base 5 plus the logarithm of x minus 2 to the base 5 equals logarithm of 2x to the base 5. Since we have an addition here, what we need to do is to multiply x plus 3 and x minus 2. So we will have the logarithm of x plus 3 times x minus 2 to the base 5 equals the logarithm of 2x to the base 5. Simplifying x plus 3 times x minus 2, we will have logarithm of x squared plus x minus 6 to the base 5 equals logarithm of 2x to the base 5. Notice in this equation that we have logarithm to the base 5 on both sides of the equation. If this is the case, then we can now simply cancel the logarithmic expression and equating the two powers x squared plus x minus 6 equals 2x. Remember that we only do this if we have logarithms to the same bases on both sides of the equation. If there is no logarithm on one side of the equation, then what we need to do is to write the equation into exponential form. Simplifying now this equation, we will have x squared plus x minus 6 minus 2x equals 0. X squared minus x minus 6 equals 0 will be our resulting quadratic equation. Since we have here a quadratic equation, therefore, we can solve the value of x by factoring. Factoring x squared minus x minus 6 equals 0, we're gonna have x minus 3 times x plus 2 equals 0. Equating both factors by 0, we're gonna have x minus 3 equals 0 and x plus 2 equals 0. Hence, x here is equal to 3 and x here is equal to negative 2. Since we have two values of x, we need to substitute these two values on our given equation here and determine which among them will satisfy the given equation. If x is equal to 3, then the equation will become logarithm of 3 plus 3 to the base 5 plus logarithm of 3 minus 2 to the base 5 is equal to logarithm of 2 times 3 to the base 5. Hence, we will have logarithm of 6 to the base 5 plus logarithm of 1 to the base 5 equals logarithm of 6 to the base 5. Remember that since this is addition, so we need to multiply 6 and 1. So we will have logarithm of 6 to the base 5 equals logarithm of 6 to the base 5. Therefore, x equals 3 satisfied our given equation. Checking for x equals negative 2, we will be doing the same thing. If x is equal to negative 2, then the equation will become logarithm of negative 2 plus 3 to the base 5 plus logarithm of negative 2 minus 2 to the base 5 equals logarithm of 2 times negative 2 to the base 5. Simplifying the powers, we will have logarithm of 1 to the base 5 plus logarithm of negative 4 to the base 5 equals logarithm of negative 4 to the base 5. Since this is addition, multiplying 1 and negative 4, we will have logarithm of negative 4 to the base 5 equals logarithm of negative 4 to the base 5. This equation seemingly satisfied our given equation. However, note that the powers should be greater than 0. Since we have here negative 4, therefore, we cannot consider the value since it is negative. Hence, the only value of x is 3. I hope that you have understood the lesson. For the next video, we will discuss about the first lesson for the quarter 2. Thank you so much for listening and see you on our next discussion.